Hello, mathematicians on the internet. Let's do some algebra. This is an equation, and we're just going to find out what x is. We have a variable term here, a non-variable term. We call these constants. So I like to move all the constants to one side and all the variable terms to the other. This one's bigger though, so I'm just going to kind of mix it up a bit here, and I'm just going to add this 3x to both sides so that my x terms can stay positive. I'm an optimist. So let's now simplify here, and this becomes a 0, so I don't have to write it. But this is a 7x now, and we still have a 3. All right, now constant terms, I guess, are moving to the left here. That kind of makes sense to get those together. And so I have -3 on both sides to stay balanced, and we have 7 negative equals 7x there. Okay. And then to get x by itself, make a ghost 1 here. Anything over itself is 1. So if you divide by 7 there, it works out really nice. And I now have this. Now that's -7 over 7. So I'm just going to change that to like a -1 equals x. Okay? So I can switch those around. I'm going to write it up here. Okay, I'm going to switch those around. Oh, hey, look, psst, x equals -1. So they told me the answer. I didn't have to do all that work. Well, kind of do if I want to show an algebraic proof. An algebraic proof is just doing the algebra, but every time you change anything at all, you have to describe what property you used that allows you to do that. So they do give you the answer when we do an algebraic proof, and they give you something to start with, which is the original equation. And they say, okay, it's like a pirate's treasure map. Here's where you are. This is x marks the spot, and get us there. Get us to the treasure, and prove that you can do each step legally, so by the rules of math. So what did I do there? That first step was called addition property of equality. This is a pretty accepted abbreviation of that. Okay, so nice to use a little shorthand sometimes. And then I took this here and I simplified it down to 7x, and I kind of rewrote things. And whenever we do a simple simplification, it's actually subbing out something complex for something simpler. So we just call that substitution. I mean, you can write simplify here, okay? But sub is a nice kind of accepted reason for simplifying here. So then what do? What's this called when you subtract on both sides? Take a cue from this. This is addition property of equality. So this would be subtraction property of equality. Ooh, property of equality. Okay, again, kind of accepted shorthand. Notice the difference between substitution and subtraction. Okay, they are a little bit different, so don't get those confused. We just need to know what everyone's talking about. So the one with the T is subtraction. After we subtracted, I substituted again. Oops. Fourth step is substitution. I substituted again, and I changed that to a 0, and I changed that, simplified to a -7. And then I divided on both sides. What would that be called? Take a cue from this and this. Division, property of equality. Okay, and I did that, and then I simplified down to -1 equals x. So that's a substitution step. But then I flipped it around, and it's easy to see that works, but it does have a name. It's called symmetric property. Oh. Symmetric property. Okay? So you see that every time we did a step, and we're very used to kind of doing these steps, we showed the path that gets us to x equals -1 by listing properties. So that's how you do an algebraic proof. And most of the proofs in the section that we're studying here are not too hard. They might have, distributive property in here. They might have you do multiplicative inverse property. So if you don't know what a step is, you might have to look it up. But it does have a name, and we're going to name each one.